This topic seems to come up very rarely at GCSE, but you need to be ready for it. So to show that an equation has a solution between some values of x, let's just think about, I don't know what this graph would look like. It might maybe, I don't know, a quartic sometimes looks like this. But let's simplify it a little bit and draw it like so. So I've drawn something that looks like y equals that thing on the left hand side, and the solution for an equation where it equals to 0 would be here, where it goes through the y-axis. Now if you look, you can see that to the right of the solution, we're going to get that the function is greater than 0, and to the left, we're going to get that the function is less than 0. So at some point, it's going to change from being negative to 0 and then to positive. And we can look at that numerically. We can try to find a sign change. That's the whole principle behind this question. Okay, so I need to show that there's a sign change between x equals 1 and x equals 2. Then I'll know that there's a solution in between, because if it's negative at x equals 1 and positive at x equals 2, or vice versa, it must at some time in between been negative, been 0. So when x equals 1, x to the 4 minus x squared minus 9 equals, and I can actually do this without a calculator, because 1 to the power of 4 is just 1, 1 squared is just 1, so it's 1 minus 1, which is 0, minus 9, which gives me minus 9. Okay, there's nothing wrong. You can put that into your calculator if you like. I'll just do it anyway. It's just that it's going to take time up. Okay, minus 9. There we go. So, and this is less than 0. X equals 2. We're going to get. Okay, I'll do this one with a calculator. We're going to get 3. So there is a sign change. It's only 3 marks, but I just need to write a conclusion. So there is a solution between x equals 1 and 2. Right, find the solution correct to 1 decimal place. That is an even more, less uncommon question at GCSE. How do we deal with this? Well, there's a few ways we can deal with it. One way in the mark scheme, I'm not going to talk about this in great detail, is to create an iterative formula. But that's not covered at GCSE, so I don't think it's worth talking about. It's a topic covered in more detail at A level. I think the best thing to do here is something known as trial and improvement. And that is to just try some values of x until you get increasingly closer to 0. And there's a few ways you can do it. I think I'm going to do it old school way, because you can use the table function, but I'm going to go halfway between the values. It doesn't take long to modify these, and I can just record my result as I go. So if I put in 1.5, I get minus 6.1875. I don't think I need to write out the whole thing, I'm just keeping track of things. Okay, now that is going to be too small. It's too, well, maybe I shouldn't say small, too low. So I need to increase my value of x. So I think I'm going to jump to 1.7. because it's actually quite a lot below 0 still. You can do 1.6 if you like, but I still get a negative here, so I've saved a bit of time. Minus 3.53. Okay, etc. Too low. I might jump to x equals 1.9 now. I'm kind of envisaging this is going to be too high. Can't say that word today, right? Aha, positive. Okay, and it's quite small, 0.4221. Too high. That just leaves us with 1.8. Minus 1.7424. So what does this tell us? It tells us if I've got my function, it's coming down. I've got 1.8, I've got 1.9. Then my function is negative here, and it's quite negative, and then it becomes positive here. However, we don't know if it's going to look like this and be closer to 1.8 than 1.9, or maybe it's going to be like this and be closer to 1.9. So there's something we need to do just to check, just to get this final little bit and find the solution correct to one decimal place. And that is, we need to look halfway in between 1.85. I'll talk a bit more about this. Actually, no, I'll talk about it now, because that will tell me if this is negative, then I'll know like it'll be like this, and then it'll be closer to 1.9. And if it's positive, then I'll know it crosses before, and it will actually be closer to 1.8. So that's why we have to do that. Quite easily forgotten or not understood, this part. Okay, minus 0.708. So what we've shown is, we don't actually know what the graph looks like, but we've just shown that it's going to be negative again, so it's going to be here. And if I was to, I don't know, this is just a possible curve, but I know, sorry, I've done it in the wrong place. I should have made it negative, like exactly on 1.85. Right, so it's going to come up maybe something like this, and then it's going to cross. But it's definitely going to cross after 1.85, somewhere between 1.85 and 1.9. And hence, if I was rounding my solution to one decimal place, it's going to round up to 1.9. Like wherever it crosses, it's going to round up to 1.9. Because I've got the sign change between 1.85 and 1.9. So I know my solution is 1.9.